All right, good morning. Today we're going to start talking about dilations. And when you hear that word, probably the most common place is at the doctor where they dilate your eyes. In that process, they do something which causes your pupils to get bigger. And when you leave, you got to wear sunglasses so the light doesn't get in because your eyes are more sensitive. Okay. Now, dilation is when it changes the size by the same amount in all directions. However, it does not just have to be bigger, it could get smaller. So, our dilation here is when it changes the size by the same amount in all directions. And as you can see up here, if it started as point xy, then kx and ky, we just multiply both of those. And if it's a number bigger than 1, it will get bigger. If it's a number between 0 and 1, it will get smaller. Now, a stretch. This is when it just changes in one direction. And a stretch means it gets bigger. Okay, so the size increases in one direction. If we look here, if it's a vertical stretch, it's going to increase in the y direction. So that's why just the y gets multiplied. Horizontal stretch would increase in the x direction, and just the x gets multiplied. And then the last one, compression. This is when it gets smaller. Compress, it gets pushed in. So compression, the size decreases in one direction. So if we look here, if it's between 0 and 1, if we multiply it, it will get smaller. Okay, the last two words here, center of dilation, this is just the fixed point about which the dilation occurs. And finally, the scale factor, this is the multiplier, or in our case, the ratio of the image to the pre-image. Okay, so some examples of that. Here's our pre-image, this apple. The dilation, as you can see, it gets bigger. Consistently, though, the ratio of the shape is still the same. It just is bigger all around, just a bigger apple. Okay, this is when it's dilation by a factor less than 1. It gets small. It's reduced in size, okay, but it's still the same shape exactly. Now, once again, the same pre-image, same apple. Here is a vertical compression. It gets smashed in the y direction. The x direction, the left to right, is the same length. This would match up the same left to right. Okay, and finally, horizontal stretch. It's the same height, but it is stretched in the x direction. So, if we look here, example 1, it says, draw the dilation of triangle PZG. Use this origin as the center, or the origin as the center, so the point 0, 0, and let k equal 3. So right from the start, if k equals 3, that's bigger than 1, we know it'll get bigger. Now, if I were you, what I would do on these is start by writing down what are P, Z, and G. What are those points? Okay, so P is right 2 and down 3. Z is right 0, or left and right 0, up 3. And finally, G is left 2 and down 3. Okay, now, P, Z, and G. We need to find what P prime, Z prime, and G prime are. So P prime, to get that, we just take 2, negative 3, we multiply each of those by 3. So that's going to become 6, negative 9. For Z prime, it'll be 0, 9. And G prime will be negative 6, negative 9. Now all we have to do is plot these new points. So P prime over here, right 6, down 9. Z prime is up 9. And for G prime, it's left 6 and down 9. Now, an important thing to note with a dilation, if you look, you can see that if we would scoot this pre-image up, Z would match right in there with Z prime. Okay, the angles do not change when it's a dilation. If we do a stretch or a compression, they will change, but the angles do not change, just the size. Okay, the angles are consistent. So our next one, example 2, it asks us to draw a dilation with a scale factor of 1/2. So we know right from the start it is getting smaller because that is less than 1. So all our points are right here for the pre-image. I'm going to start by plotting those. So there's A, B, C, and D. And we'll connect our dots. All right. Now, to find our pre-image, just multiply each of those by 1/2. So A prime becomes -2, -1. B prime, -3, -2. C prime becomes -2, -3. And D prime, the final one, -1, -2. So as you can see, it is still a square, just smaller, and therefore closer to the center of dilation, or the origin in our case. Okay, two more. Example 3 here. Once again, they give us the coordinates A, B, and C. So let's plot those. 1, 3. That's A. 1, -1 is B. And C is at 4, 3. And it does tell us this is a right triangle. Okay, now it has a scale factor of 2, so it's going to get bigger. So 1, 3 becomes 2, 6. 1, -1 becomes 2, -2. And 4, 3 becomes 8, 6. So I'll plot this over here in red. There's A prime, B prime, and C prime. Now this one asks us a final question. It's a little different. It says, what is the length of the hypotenuse? So we need to think back to August. This is a right triangle. The hypotenuse would be the longest side, also this side over here. Good news is a squared plus b squared equals c squared. We can easily figure out what that hypotenuse is, and we can know what the two sides are if we just count them. They're horizontal and vertical. So 1, 2, 3, 4, 5, 6. Up and down, it's going to be 8. So 6 squared plus 8 squared equals c squared. 6 squared is 36. 8 squared is 64. 36 plus 64, that's going to give us 100, which equals c squared. Take the square root, and c will equal 10. Hypotenuse is 10. Okay, our final one. Draw a horizontal stretch. So you know it's going to stretch in the x direction. Okay, the height will stay the same, and it has a scale factor of 3, so we got to put a 3 here, 3x. The height does not change, so I can put a 1 there. Now let's plot these original points. Whoops. So 2, -1. That's D. 4, 5. That's E. C is -1, 1, 2, 3. And there's our shape. So if we are going to find our result or our image, D prime will become 6, -1. The y does not change. E prime. Also, this was supposed to be an F, wasn't it? It's a typo. I said triangle DEF and then forgot to change it there. Okay, so E prime will be 8, 5. No, not 8, sorry. 12, 5. It's a scale factor of 3. And finally, F prime would be -3, 3. So F prime will be right there. D prime will be there. And E prime a little bit off. That's okay. We connect our dots. As you can see, the shape will not have the same angles anymore. It is stretched horizontally, stretched along the x-axis. Okay, the height is still the same from -1 up to 5, but it is stretched left to right. So that is all I have for today. If you have any questions, please reach out. There is a Delta Math assignment, probably the easiest one of the whole year. So please get that done. Hope you guys have a great day, and I'll talk to you later. Bye.